Lesson 8, magma plumes, often referred to as hotspot theory. This theory is companion to plate tectonics theory with the convection cell, the ridge push, and the slab pull. And you might argue it's still part of the same thing, but often the essays that are set up where you're evaluating the usefulness of plate tectonics theory, this can be also, but on the other hand, but I think this works alongside it. And the reason for this is that we get earthquakes and volcanoes that are well away from plate boundaries. So, hundreds and sometimes thousands of kilometers away, in particular, volcanic activity. And you're thinking, well, that doesn't seem to marry up with then the plate boundaries that we've been taught about. So anyway, let's check this out a little bit more. So I often refer to them as hotspots. They are referred to as hotspots, but in the specification, they are referred to as magma plumes. So again, the language they could use in the exam is really important to get right. So let's just point this out, and you can see we've had this last few lessons where we've systematically worked our way through all these plate boundaries, the landforms, the key processes going on with them, and we're kind of coming to this last strand here. So magma plumes, hotspots. And I've established a little bit of the link of where it happens and how that sits maybe in a 9-mark or 20-mark response. And let's face it, you could be asked in a 4-mark response, explain the concept of hotspot theory or magma plumes and the landforms that they create. And not too long of a video. So if you look at this one here, we're talking about a hotspot where we have, the theory goes, there's a plume, which is like a jet, if you think of a flame coming up, in a fixed position coming from the outer core, rises up through the mantle and burns its way through in a fixed point on the crust. And the crust itself moves a bit like a conveyor belt. Okay? And therefore, what happens is when the magma breaks through on the ocean floor, for instance, then you have a volcano, and then over hundreds of thousands of years, possibly millions of years, because the movement is so slow, that volcano builds and it builds, and it can produce an island that comes out of the sea, continues to erupt slowly, and you can see with the diagram here, you can see the tip coming out here, it slowly moves away, and it moves away from that hot spot, and the volcanic activity calms down and eventually stops, and you get this series of islands that are formed. And when the islands move away from the hotspot over a period of time, they're broken down by marine processes, subaerial processes, and they erode away. That will be shown quite clearly in the next slide. You'll notice there is an animation on here, so when you look at the PowerPoint, PDF, whatever format that you've got it in, you can click on that and see these things actually in action. The world's tallest mountain, you heard it, which is Mauna Loa in Hawaiian Islands, from the base to the top, because a lot of it's under the sea, it's been formed this way. So if we look at the picture here, there's our plume, there's the lithosphere as such. This would be our active volcano, and over a period of time that would incrementally get larger and larger, break the surface, form this island, and then as this would then become this, become this, become this. But in the modern day, you see a series of these islands. So at some point in the past, that would have been all the way over here. And you can see there's this degradation of the island structure over time. Okay, quite straightforward in terms of depth. There's not a massive amount of variation that we need to go into this. You also get hotspots under continental plates. Yellowstone supervolcano, which we don't really touch on in this unit in any particular depth. It's not an essential thing. That's formed under continental crust. That's formed under the North American plate. So there are hotspots all around the world. And this is probably the best animated slide that I could find. It's a bit too quick, but it does kind of illustrate a little bit of what's taking place. The focus here is on Hawaii. And just a few specifics about the Hawaiian Islands. So you can see the Pacific plate is moving at 9 centimeters per year. This is moving in a northwesterly direction. Look, it's over 3,000 kilometers away from the nearest plate boundary, and you can see there are a series of islands. So here's the youngest, where you've got active volcanoes already, and you can see here's the hotspot, that plume coming up, and these islands here, you can see they are getting smaller. Eventually, they will be under the sea, and you can see they will. Well, you can't see, but you speculate, extrapolate that these used to be in this position here. That's pretty much all of it is. I mean, again, you can see there's a clip that you can go onto. You've got your textbook, but make sure you have practiced these. Okay, so this is the last in the series of these. And just to repeat, this bit of theory is an additional bit of theory because it's okay. So plate tectonics theory explains like plate boundaries, volcanoes, earthquakes, landforms. But there's all these volcanoes and earthquakes elsewhere. Well, not saying so much about earthquakes, but certainly we have an additional theory that doesn't contradict that plate movement theory that you talked about before. It's like an additional bit. Okay. So this is the end of that particular section of the syllabus. The next section they'll go on to is volcanicity. In that, we talk about types of volcanoes, causes of volcanoes, the key characteristics, the primary and secondary hazards of that. You look at the other sort of like social economic impacts, and then you have a case study which is most likely to be Mount Pinatubo, but I haven't yet decided on that one. And like all these things, you look at the causation, you look at the impacts, we look at the response, the management, and strategies that can be put into place to, cope with volcanic eruptions. Okay, thank you very much for listening. See you next lesson.